Hello students, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem 4 from chapter 8 that is related to the friction. So the problem says that the winch on the truck is used to hoist the garbage bin onto the bed of the truck. If the loaded bin has a weight of 8500 pound and center of gravity at G, determine the force in the cable needed to begin the lift. The coefficient of static friction at A and B are 0.3 and 0.2 respectively. Neglect the height of the support at A. So now we have this garbage bin and its center of gravity is located somewhere here, and it is in contact with the surface at point A, and it is in the contact with this inclined surface of the truck, of this winch. So let's say if we draw the free body diagram, so let's say that this rectangle represents that garbage bin, and this orange line is parallel to that winch, which is making 30° with the horizontal. So at A, we will have the normal reaction at A, which is going to act, the surface is going to apply the NA. The reactions at A is, let's say, NA, and at point B we will have NB, but that NB will be perpendicular to the inclined surface, right? We will have NB perpendicular to this, right? Since this point B is lying on this incline, so this incline is going to apply the normal force perpendicular to this line. So let's have that NB reaction, which is going to act in this direction. This will be our NB. And similarly, since we have this cable, so this cable will apply the force in this direction. So we will have tension T going up, right? So let's say that we have that tension T, which is applied in this direction. This is the tension T. And as we know that since the friction is involved, so this tension will try to lift this garbage, and this point B will, this tension T will try to move this garbage along this line. So the friction force will resist this motion. So the friction force at B will act in the opposite direction to the applied external force. So here we will have friction force at B. We will have FB, and this FB will be equal to mu B times NB, and we are given that mu B in the problem statement, it is equal to 0.2. This is 0.2 times NB. So this is FB, which must be acting in the opposite direction of the external force. The external force is the tension applied by the cable. Similarly, here, since this garbage bin will move towards the right, so this point A is along the horizontal surface. So this point A will move towards the right. So the external force on this point A is acting towards the right. So in order to oppose this, the friction force at A will act in the opposite direction, that is towards the left. So we will have the friction force at A, and the friction force at A, that will be equal to mu A times NA, is mu A times NA, and mu A is 0.3, it is given, times NA. And it is said that since we are using this static friction, since we are using the coefficient of static friction, so this will give us T value, which will just start lifting, right? In the problem statement, it said that determine the force in the cable needed to begin the lift. So it will just start the lift. We will have that T value above which the motion will be started, right? So we need to find that value of T. So that is why we are going to use the static friction, right? So before the start of the motion, the whole system is in equilibrium. So here we are going to apply the equilibrium conditions. So Somewhere here we have that point G, and at point G the weight of the bin is going to act. So let me draw that weight vector. We will have that weight, and it is acting at point G, and its weight, the weight is equal to 8500 pounds. Now a point G is at a distance of, it is given that it is at a distance of 10 feet, and the distance between point G and point B is this is 12 feet. So let me remove this, right? So now, since we are going to apply the equilibrium condition, so first of all we are going to apply the summation of forces along x equals to 0, and this is our positive x direction. So for that, to apply this equation, we have to resolve all the forces along the x and y direction. So this is my positive x, this is my positive y, so I have to resolve all these forces. So now we can resolve this T, we can resolve this tension applied by the cable into its components. So we will have one component like this one will be the cos component, so this will be T cos of 30, and we will have one component going to act in the upward direction like this. So this one will be the sine component. This component is the sine component, so we can say that this is T sine of 30. Similarly, since this FB is acting along this incline, so if we have 30-degree angle here, so we will have 30-degree angle here, so we have 30-degree angle here as well. So now we can resolve this FB, so we will have one component of FB which is going to act in this direction. So this one will be, if this is 30-degree, then this will be FB cos of 30. And similarly, we will have one component in the downward direction. This one will be the sine component. So this one is FB sine of 30. And similarly, this and B reaction is perpendicular with this line. And similarly, if I draw a vertical line here, so this vertical line is perpendicular with the horizontal. So if the angle between these two is 30, then the angle between NB and the vertical line is also 30 degrees. So let me write that this NB is also making 30-degree angle. So now we can say that this is one component of NB. It is going in the upward direction. So this one will be the cos component, since the angle is made with this component. This one is the cos component, and we have this component as well. This one is the sine component. So this component of NB, this is the cos component, this one is the sine component. Let me draw it here, right? This is NB, and it has one component like this, and it has one component like this. So this component is NB cos of 30, since we have 30-degree here, and this one is NB sine of 30 degrees. So now we can apply the summation of forces along x. So we apply this, if we apply the summation of forces along x, so we have T cos of 30, which is going to act in the positive x direction. This is our positive direction, so I will write T cos of 30. Then we have this FB cos of 30, it is going to act in the negative direction, and FB, we know that FB is 0.2 NB, so we will write minus 0.2 NB cos of 30. Similarly, we have this NB sine of 30 component in the negative x, so I will write minus NB sine of 30, and this must be equals to and similarly we have this FA component which is acting in the negative x, so we will write minus, and FA is 0.3 times NA, so minus 0.3 times NA, this is equal to 0. So as we can see that since we have applied the summation of forces along x, we have this one equation, and we have three unknowns, T and B and NA. So if we have applied the summation of moment about point B, so that equation will give us the magnitude of NA. So now before going to apply the summation of forces along x, we need to apply the summation of moment about point B. Let me apply the summation of moment about point B equals to 0. So all these forces which are acting at point B, their moment about point B is equal to 0. So they will not come into our equation. So we will have the summation of moment about point B equals to 0. And let's assume that the counterclockwise moment is positive. So now, as we can see that this and A is producing the clockwise moment about point B. So I will write minus and A, and the perpendicular distance of this and A from that point B is this distance, which is equal to 10 plus 12, which is 22 feet. So I will multiply this with 22. And similarly, this 800-pound force is producing the moment in the counterclockwise direction about point B. So I will write plus 8500, and the perpendicular distance of this weight from that point B is this distance, which is 12 feet. So we will multiply this with 12, and this FA is passing through the line of action of this FA is passing through that point B, so it's not going to produce the moment about that point B. So if we apply the summation of moment about point B, we get this, and this is equal to 0. So now from this we can say that minus NA into 22, this is equal to minus 8500 into 12. And if we divide both sides of equation by minus 22, so this will cancel out and we will have an A equals to, so this is 8500 multiplied by 12 divided by 22. So we get 36.36 pounds. So we get the magnitude of an A. Now this will make our life easier, since in this equation we will have two unknowns. Now we know an A, right? So I will plug in that value. So we will have this equation is T cos of 30 minus 0.2 and B. And let's take and B common from both of these terms, right? So I can write that this is, let me write this is minus and B. So this will be 0.2 cos of 30 plus sine of 30. And if I bring this to the other side of equation, so it will become positive. So we will have plus 0.3 times NA, which is 36.36. So 0.3 into our answer. So answer multiplied by 0.3. So this gives us 1390.90. So this is equal to 1390.90. And now let's find this. So this is 0.2 cos of 30 plus sine of 30. This gives us 0.673. So we can write that this is T cos of 30 minus 0.673 and B. This is equal to 1390.90. Let's say this is our equation 1. Now if we apply the summation of forces along the y-axis, that must be equals to 0, and this is our positive y direction. So the forces acting in the upward direction are considered to be positive, since this is our positive y direction. Now we have this T sine component which is acting in the upward direction. So I will write T sine of 30. Then we have this green component, which is the NB cos of 30. It is acting in the positive direction. So I will write plus NB cos of 30. And then we have this FB sine of 30. This is acting in the downward direction. So I will write minus NFB is 0.2 NB sine of 30. Then we have this NA, which is going to act in the upward direction, and we know the magnitude of NA, which is 4636.36, and the weight is acting in the downward direction, which is 8500 pounds. So minus 8500 pounds. So this is equal to 0. So now we can write that this is T sine of 30, and if I take NB common from these two terms, so we can write that NB cos of 30 minus 0.2 sine of 30. And we can bring these two terms to the other side of equation, so their signs will become opposite. So we will have 8500 minus 4636.36. So now let's find that 8500 minus 36.36. This gives me 3863. So this is 3863.64. And now let's find this, which will be the coefficient of NB, that is cos of 30 minus 0.2 sine of 30. This gives me 0.766. So this is T sine of 30 plus 0.766, and B equals to 3863.64. So now from equation 1, from this particular equation, we can write that NB from this equation, we can write that NB is equal to 1390.90 minus T cos of 30. If I bring this term to the other side of the equation, so it will become negative. And then if I divide, we will have here we will have minus 0.673. So now if I divide both sides of equation by minus 0.673 minus 0.673, so this will cancel out and we will be left with NB. So we have NB in terms of T. So now we have this equation. So now if we plug in this NB in this equation, let's say this is our equation 2. So we will have T sine of 30 plus 0.766 times NB. Now NB is 1390.90 minus T cos of 30 divided by minus 0.673 equals to 3863.64. Now we can divide both of these terms by this constant, right? So we can write that this is we can write this as 1390.90 divided by minus 0.673, and this divided by minus 0.673. So this is like this. And now we can multiply this inside, right? So this will be T sine of 30 plus 0.766 into 1390.90 divided by minus 0.673, and then minus 0.766 T cos of 30 divided by minus 0.673. And if you multiply this minus sign with this, so this will become positive, right? So we can say that this is plus, this is plus, and this is plus, right? And this is equal to 3863.64. So now let's find all these constants. This is 0.766 into 1390.90 divided by minus 0.673. So this term is minus 1583.10. And similarly, we can multiply this with this cos of 30 and divide it by this. So this is 0.766 into cos of 30 divided by 0.673. So this is plus 0.986t equals to 3863.64, and here we will have T sine of 30. So now we can add both of these terms. Sine of 30 is 0.5. This is 0.5. Let me write it. This is t sine of 30. So this is 0.5 t. So now let's add both of these terms and let's bring this to the other side of equation. So we will have 0.5 plus 0.986. So this is 1.486 t, 1.486 t. And this will be equal to 3863.64 minus, so this will become positive on the right hand side of equation. So we will write plus 1583.10. So 3863.64 plus 1583.10. So this gives me 5446.74. This is equal to 1.486 t. Divide both sides of equation by 1.486. This will cancel out. We will have t value. So now this answer divided by 1.486. This gives me t value equals to 3665.37 pounds. So this is that t value which is required in the cable to just begin lifting this garbage bin. So this is the solution of this particular problem. I hope it will help you in your learning. It's a bit lengthy problem, but I hope it will help you. Do let me know in the comments if it helps in your learning. Also subscribe my channel for such more problem solution, as it will help me to expand my audience. So do subscribe in order to reach many more students like you, which is my goal of this channel.